Namaskar students. In today's video, we shall see how Lagrange's mean value theorem can be applied to solve some standard inequalities of the real number system. So let us start today's video. So this is the first problem of today's video. X by 1 plus x less than log of 1 plus x less than x. This is what you have to prove where x is greater than 0. Now, to solve these type of problems by using Lagrange's mean value theorem, it is very important to know which form of Lagrange's mean value theorem you have to consider for these type of problems. See over here where you have it is given that x is greater than 0 only, where no interval is prescribed. So it is advisable to consider this form of Lagrange's mean value. If you have remembered that there was a form of Lagrange's mean value theorem for a function fx in the interval 0x, which says that if fx is continuous in this interval and if x is differentiable in the open interval of 0x, then we can write fx as fx equal to f0 plus x f dash theta x, where theta lies between 0 and 1. In other words, you can say like that, 0 less than theta less than 1. So this was one form of Lagrange's mean value theorem that we had discussed in our previous videos. If you have missed those videos, you can go over there and see that video. So this is the form which we shall consider for solving this problem. Now another thing that you must keep in mind is what fx shall you assume for a particular type of problem. See, for this problem, you have a log of 1 plus x in the mid portion. And if you do a differentiation of log of 1 plus x, what do you get? 1 by 1 plus x. So a form of 1 by 1 plus x, even though an x is over there, doesn't matter, a form of 1 by 1 plus x is also there. So it is safer to assume fx, consider fx equal to log of 1 plus x. Now this assumption is mainly based upon a particular type of problem. When the problem changes, then the assumption of fx also will change. There is no hard and fast rule or formula to actually understand what fx shall you assume. It is by mere intuition and understanding of the problem that you have to assume the function fx. So for here, we have considered fx equal to log of 1 plus x. Now if we have to apply that Lagrange's mean value theorem's form over here, let us see. Now this fx log function is continuous, there is no doubt about it. Now what happens if we do like this? Now first case, fx equal to log 1 plus x is continuous in 0x, where x is greater than 0. That we all know. That is a property of this function log of 1 plus x. Secondly, the function's derivative f dash x. What is the derivative? 1 by 1 plus x. Now say this function will become undefined if x is equal to minus 1. Because if x is becoming equal to minus 1, then in the denominator part you are getting a 0 and the function is getting undefined and discontinuous point is coming up over here for x equal to minus 1. But for this problem, it is given that x is greater than 0. So no question of x being minus 1. When x is greater than 0, this function is always continuous. So f dash x equal to 1 by 1 plus x exists in the open interval 0x. So both the assumptions for the Lagrange's mean value theorem are satisfied over here. Then we can consider, therefore, fx equal to f of 0 plus x f dash theta x, where 0 less than theta less than 1. This was the form of Lagrange's mean value theorem that we took to consider for this problem. Now let us just put the expressions, or so what is fx? Log of 1 plus x equal to f of 0. Now if fx is log of 1 plus x, f of 0 is log of 1 plus 0, that is log 1 plus x f dash theta x. Now f dash x is 1 by 1 plus x. So f dash theta x, just put theta x in place of x. So it will be 1 by 1 plus theta x. So into 1 by 1 plus theta x, where 0 less than theta less than 1. Or you might write this as log 1 plus x equal to x by 1 plus theta x, where 0 less than theta less than 1. So log of 1 plus x, you are getting that one is equal to x by 1 plus theta x. So this is the final step that we have reached. Log of 1 plus x equal to x by 1 plus theta x, where 0 less than theta less than 1. Now let us move on with the problem with this inequality 0 less than theta less than 1. Now what happens if we consider this 0 less than theta less than 1? Now if you multiply both sides, all the sides with x, what happens? 0 into x less than theta into x less than 1 into x. Or in other words, you can say that, or 0 less than theta x less than x. We can do this without changing the inequality sign because x is greater than 0. Why? Because since x is greater than 0. Okay, that we can write in the previous line only. Since x is greater than 0. Or now our point is to bring this form. Okay, so we have got theta x. Now if you add all the sides with 1, so 0 plus 1 less than, so 1 plus 0 less than 1 plus theta x less than 1 plus x. It's okay with that? Or 1 plus 0 means just 1. So let us write 1 over here. Okay. Now what happens if we consider the reciprocal of this? Now when we consider the reciprocal of this, that is 1 by 1 by, then the inequality sign will change. That we'll know with the property of inequality. So we can write 1 by 1 greater than 1 by 1 plus theta x greater than 1 by 1 plus x. Since we are considering the reciprocal, so the inequality sign is changing. Now 1 by 1 means 1. That's why we have written 1. Or we can write this one as, now in all the sides, if we multiply an x, what happens? X greater than x by 1 plus theta x greater than x by 1 plus x. Why? Since x is greater than 0. Since x is greater than 0, so we can multiply x in all the sides without changing the inequality sign. Or now what is this? X by 1 plus theta x means log of 1 plus x. So we can write this as x greater than, see, x by 1 plus x means log of 1 plus x, log of 1 plus x greater than x by 1 plus x. Now if we just change this, see, x by 1 plus x is actually less than this, which is actually less than this. So we can write that x by 1 plus x, which is less than log of 1 plus x, which is less than x. And this is the inequality that we needed to prove. Okay. So this is our next problem. Prove that 0 less than 1 by x into log of e to the power x minus 1 by x less than 1, where x is greater than 0. So you have to prove this inequality. Now we will use the same form of Lagrange's mean value theorem that we had used in the previous problem. The thing is that what fx shall we assume? Here we shall assume, consider fx equal to e to the power x in the interval 0x, where x is greater than 0. Now see, the function fx equal to e to the power x, first of all, this function fx equal to e to the power x is continuous in 0x. Exponential function is always continuous, that we know. Secondly, what happens if we do a derivative f dash x? That is the same exponential function once again exists, so it exists at all points in the interval 0x. So both the conditions for Lagrange's mean value theorem are satisfied. So we can consider by Lagrange's mean value theorem, fx equal to f of 0 plus x f dash theta x, where 0 less than theta less than 1. Therefore, now if we just put the expressions, fx means e to the power x equal to f of 0. F of 0 means e to the power 0 plus x f dash theta x. Now f dash x equal to e to the power x, so f dash theta x equal to e to the power theta x. Or now from here, what are you getting? See, from here we are getting, if we want to find out e to the power theta x, then e to the power theta x equal to e to the power x minus e to the power 0 by x. This is actually 1. E to the power 0 means 1. So e to the power x minus 1 by x. See, more or less we are arriving at these type of forms. So e to the power theta x equal to e to the power x minus 1 by x. Now what happens if we consider a log on both sides? Log e to the power theta x. Okay, log with base e. Log with base e equal to log of then e to the power x minus 1 by x. Now if the log's base is e, log base e to the power theta x, then by the property of logarithm we know that this is actually theta x. So this is actually theta x, which is equal to log e to the power x minus 1 by x. So from here we are getting theta equal to 1 by x log e to the power x minus 1 by x. Theta equal to, this x will go that side, it will be getting divided. So theta equal to 1 by x log e to the power x minus 1 by x. Now what is this theta? This 0 less than theta less than 1. Therefore 0 less than theta less than 1 implies 0 less than, what is the value of theta? 1 by x log e to the power x minus 1 by x less than 1. This was the inequality that was needed to prove. This is the last problem of today's video. It's a bit different from the previous two problems to some extent. To what extent, that we are going to see after a few minutes. But as of now, let us look at this problem. It is saying that you have to prove that 1 plus x by 2 root over 1 plus x less than root over 1 plus x less than 1 plus x by 2, where x is not greater than 0, but x lies between minus 1 and 0. So over here, the Lagrange's mean value theorem that you have to consider for not 0x, not for 0x, no, but for, since x is less than 0, so you have to consider for x0. That is the difference in this problem from the previous two problems. Now what is the fx that you should consider for this problem? Let us consider fx equal to this one, root over 1 plus x. Normally the function that you need to consider, that you have to see in the middle portion what is there. By looking at the middle, see in the previous two problems also, whatever was there in the middle portion, that was actually deciding what fx shall we assume. So over here also, since fx equal to root over 1 plus x, we have considered fx equal to that root over 1 plus x, which was in the middle portion, in not 0x but x0, since x is less than 0. Now see, this function, if this function has to be undefined in real number system, so some negative shall be considered within the roots. Since x is not beyond, not less than -1, so over here inside the roots there cannot be any negative, because for inside the root, for this one to this portion to be negative, x the value of x shall be would be either equal less than -1. Okay, if x is less than -1, then you shall have a negative portion within the square root. But since that is not the case, so it's okay. So over here fx equal to root over 1 plus x is continuous obviously in x0. Why? Since -1 less than x less than 0. Since the value of x is not less than -1. If the value of x would have been less than -1, then you would have got a negative within the roots. So that is not the case. Number 2. Now derivative. What is the derivative of this? If you do a derivative, it will be 1 by 2 square root of 1 plus x. You can do a derivative of this one in your copies. You see it will arrive at 1 by 2 root over 1 plus x. Now see 1 by 2 root over 1 plus x. Since x is not equal to -1, x is greater than -1, not equal to. If x would have been equal to -1, then you would have got a 0 in the denominator part, which would have made this function undefined. Okay, but since that is not the case, so this function is well defined for all values of x within -1 and 0. So we can tell exist in open interval x0. Same reason as this. Okay. Now considering this too, so you can consider, therefore by Lagrange's mean value theorem, you can tell fx equal to f0 plus x f dash theta x, same thing for 0 less than theta less than 1. Now let us put the expressions. Fx means root over 1 plus x. What is f of 0? Put 0 over here. Root over 1 plus 0 plus x f dash theta x. Put theta x in place of x into 1 by 2 square root of 1 plus theta x. Or in other words, you may write root over 1 plus x equal to, this is square root of 1 means 1, equal to, so 1 plus x by 2 root over 1 plus theta x. Remember this line, because this line is the anchor part of this problem. So this was the last line that we had got in this problem. Now we all know that now 0 less than theta less than 1. Now what will happen if you multiply x throughout? See over here in the previous problem what we had done, we had multiplied x throughout and we had got 0 less than theta x less than x. But over here x is not greater than 0, x is a value which is less than 0, so x is negative. So if you multiply a negative quantity throughout, then the inequality sign changes its direction. So if you multiply over here x throughout, 0 into x is 0, greater than, it will be greater than theta x greater than x. Why? Since x is negative, x is less than 0. Or now let us add 1 throughout. So 0 plus 1 is 1, greater than 1 plus theta x greater than 1 plus x. Now you can do a square root also over here. So square root of 1, square root of this, square root of this, it will not affect the inequality. Or you can multiply at 2 throughout. What happens? It will be 2 greater than, square root of 1 is 1. Over here you shall not consider minus 1 over here. Consider only 1, the positive part. So 2 into root over 1 plus theta x greater than 2 into root over 1 plus x. or now let us do the reciprocal of this, because we are wanting to arrive at this portion. So 2 root over 1 plus theta x we have got. Now if you do a reciprocal, so it will be 1 by 2 now less than, because since we are doing a reciprocal, again the inequality sign will change. So 1 by 2 square root of 1 plus theta x less than 1 by 2 square root of 1 plus x. Now again, see, you have a x over here. So you have to multiply x throughout, because we are wanting to arrive at this over here in the middle portion. So if you multiply an x throughout now x is negative. So x being negative, again the inequality sign will change. So x by 2 again greater than x by 2 root over 1 plus theta x greater than x by 2 root over 1 plus x. Now a plus 1, or 1 plus x by 2 greater than x by 2 1 plus x by 2 root over 1 plus theta x less than 1 plus x by 2 root over 1 plus x. So this is greater than. Now we can just put this one this side, just the reverse. If we just write the reverse, then what we have, this one at first 1 plus x by 2 root over 1 plus x less than 1 plus x by 2 root over 1 plus theta x less than this one 1 plus x by 2, or see, now 1 plus x by 2 root over 1 plus theta x means nothing but root over 1 plus x from here. So this one is equal to root over 1 plus x, that means this portion is becoming equal to square root of 1 plus x, or 1 plus x by 2 root over 1 plus x less than root over 1 plus x. This one is root over 1 plus x, which is less than 1 plus x by 2, the inequality. So this was the inequality that we thought of achieving. So my dear students, this is all what we had for today's video. If you have understood the problems discussed in today's video, do share this video with your friends, subscribe to my channel, like my video, and don't forget to follow my page. Till then, goodbye.